In the summer of 1943, the sky over Hamburg burned like an open furnace. During Operation Gomorrah, the Royal Air Force and the United States Army Air Forces unleashed a firestorm. Temperatures rose high enough to melt asphalt. Air was pulled into the center of the inferno with the force of a thermal hurricane. More than 30,000 people died within days. This was no longer tactical bombing. It was a systematic assault on the industrial heart of Germany: Essen, Cologne, Berlin, Schweinfurt, steel works, ball-bearing factories, aircraft engine plants. Each one became a target. The ball-bearing plants in Schweinfurt, supplying components essential to nearly every German military engine, were struck heavily in August and October of 1943. A ball bearing is small. Without it, engines stop. When engines stop, war slows down. In the East, defeat at Stalingrad had shattered the myth of invincibility. In North Africa, Axis forces surrendered in Tunisia. In the Atlantic, U-boats were being hunted more effectively through radar and code breaking. Nazi Germany was being squeezed from every direction, and in that pressure, it chose a different path. Not retreat from war production, not negotiation, not reduction. It chose to dig. In February 1942, Albert Speer became Minister of Armaments and War Production. He was not a general. He was an architect. He understood structure. He understood scale. And above all, he understood organization. Under Speer, German weapons production actually increased in 1943, despite the intensifying bombing campaign. He centralized management, reduced redundant weapon designs, and relied heavily on forced labor from occupied territories. But Speer also saw what many preferred not to admit. The Allies had gained air superiority. Factories on the surface were exposed. Cities were vulnerable. His solution sounded logical in engineering terms. Bombs can destroy factories. Mountains are harder to destroy. The concept was not entirely new. Some underground fuel depots and storage sites had been built before the war. But beginning in 1943, relocation underground became policy. The program was called U-Verlagerung, relocation below ground. In the Harz Mountains, near Nordhausen, an abandoned gypsum mine offered a vast network of tunnels. It would become the production center for Germany's most ambitious weapon, the V2 rocket. After the Peenemünde Research Center was bombed in August 1943, Germany moved rocket production underground. The mine was expanded. Tunnels were widened. Chambers were reinforced to house assembly lines. The new facility was named Mittelwerk. The adjacent labor camp was Mittelbau-Dora. Inside, concentration camp prisoners, many transferred from Buchenwald, were forced to work in suffocating darkness. They slept inside the tunnels. They worked 12 to 16 hours a day. They lacked food, medical care, and clean air. Thousands died from exhaustion, disease, malnutrition, or execution. The V2 was presented as a wonder weapon. Yet more people died building it than were killed by its impact. In the shadows of Mittelwerk, advanced engineering and human brutality coexisted. Mittelwerk was not unique. By war's end, Allied investigations identified hundreds of major underground facilities across the Third Reich. Plans mentioned even more. In Austria near St. Georgen an der Gusen, the Bergkristall complex produced components for the Messerschmitt Me 262, the world's first operational jet fighter. The Me 262 was faster than any Allied bomber. Armed with heavy cannon, it could tear through bomber formations in seconds. But production was delayed by fuel shortages, limited pilot training, strategic interference from Hitler, and disruption across supply lines. Moving production underground reduced vulnerability to bombing. It did not solve every problem. In Lower Silesia, the vast Riese project carved enormous tunnel systems into the Aal Mountains. Its intended purpose remains debated. Perhaps a new headquarters, perhaps an industrial complex. Tens of thousands of forced laborers worked there. Many never left. In northern France, massive concrete structures such as La Coupole were built to assemble and launch V2 rockets. Their concrete domes were several meters thick. The Allies responded by developing specialized deep penetration bombs capable of cracking reinforced concrete. War was no longer fought only across fields and seas. It was fought against stone. In Berlin, leaders placed their hopes in technological breakthrough. The V1 flying bomb struck London beginning in June 1944. The V2 ballistic missile followed in September. No warning siren, no interception. The psychological impact was significant, but strategically it was insufficient. Production goals aimed for 1,000 rockets per month. Actual output rarely met that mark. Many early rockets failed due to technical defects. Meanwhile, synthetic fuel plants were bombed relentlessly. Without fuel, even advanced jets and submarines could not operate effectively. Underground production could protect factories from bombs. It could not produce oil. By late 1944, Germany could no longer defend its skies. Rail networks were shattered. Raw materials failed to arrive. Finished weapons could not be transported safely. The Underground Reich became a complex system without arteries. The ultimate symbol was beneath Berlin itself. In January 1945, Soviet forces launched a massive offensive and advanced rapidly westward. Berlin was encircled. Hitler retreated into the Führer bunker beneath the Reich Chancellery. The image was stark. A regime that once built monumental boulevards and grand architecture now operated from reinforced concrete beneath the earth. Orders continued to be issued for divisions that no longer existed, and beneath mountains across Germany and Austria, production struggled on. Weapons were assembled for an army already collapsing. By the end of 1944, the map told a clear story. In the west, Allied forces had broken out of Normandy and advanced through France and Belgium. In the east, Soviet armies pushed through Poland toward Germany. In the south, Italy was faltering. The Underground Reich was no longer a calculated advantage. It was a measure of desperation. Scarce resources were poured into concrete, tunnels, and unfinished projects. In many facilities, only a fraction of planned space was completed before the war ended. Drill holes remained unblasted. Machinery stood idle. Abandoned tools lay scattered, as if workers had stepped away for lunch and never returned. When American forces entered Nordhausen in April 1945, they found more than rocket parts. They found bodies. They found survivors reduced almost beyond recognition. The Underground Reich was not only a story of technology, it was a story of ambition sustained by coercion. Within those tunnels, steel and engineering tried to prolong a collapsing state, but wars are not decided by weapons alone. They are decided by logistics, by fuel, by people. And by early 1945, Germany had exhausted all three. June 6, 1944. Dawn over Normandy did not begin with sunlight. It began with engines, thousands of aircraft, naval guns thundering from the channel, paratroopers descending into darkness. D-Day was not only an amphibious invasion, it was confirmation that Germany had lost the initiative. For nearly 4 years, the Wehrmacht had dictated tempo, choosing when and where to strike. Now the Allies chose the battlefield. Within weeks, beachheads solidified into ports. Within months, France was collapsing back into Allied control. Airfields were established close to the German border, and that changed everything for the Underground Reich. Until mid-1944, many underground facilities were threatened from above, but insulated from ground assault. Now Allied armies were advancing toward them. Concrete domes in northern France, launch sites hidden in forests, rail junctions feeding tunnels in central Germany. Distance was shrinking. In Pas-de-Calais, Germany had built massive reinforced structures to support V-weapon deployment. One of the most ambitious was La Coupole, a colossal concrete dome intended to assemble and launch V-2 rockets toward London. The dome was thick enough to resist conventional bombing. Engineers believed it could survive direct hits, but the Allies adapted. The British introduced the Tall Boy, a deep penetration bomb designed to punch through reinforced concrete before detonating underground. The result was devastating. Mimoyex, a site prepared for the long-range V3 supergun, suffered catastrophic damage. La Coupole was neutralized before becoming fully operational. The lesson was clear. There was no such thing as permanent invulnerability. Every defense invites counter-innovation. Underground construction was a shield, but shields can crack. Allied reconnaissance had matured into a precise science. High-altitude photographic missions mapped industrial zones with obsessive detail. Analysts compared shadows, ventilation shafts, rail traffic, and excavation patterns. At Nordhausen, unusual train movements drew attention. Rail lines disappeared into mountainsides. Vent stacks multiplied. The pattern suggested something more than storage. By late 1944, The Allies understood that large-scale production had moved below ground, yet bombing tunnels directly posed challenges. Entrances were narrow, rock-absorbed shock waves. Prisoner presence, though not fully understood at first, complicated decisions. Instead, the Allies attacked supply chains. Railways were bombed repeatedly. Bridges were destroyed. Synthetic fuel plants became primary targets. An underground factory still needs electricity. It still needs steel. It still needs transport. Cut the arteries and the organism weakens. In the summer of 1944, Mittelwerk reached its highest production tempo. Hundreds of V2 rockets per month rolled through the assembly halls carved from gypsum rock. Each rocket required tens of thousands of parts. Guidance systems, fuel pumps, combustion chambers, complex components assembled under brutal conditions. But production targets were often missed. Technical defects plagued early batches. Rockets exploded at launch. Guidance errors caused misfires. Prisoners were marched away under brutal conditions. Equipment was sabotaged in some cases, abandoned in others. Production did not stop cleanly, it unraveled. Electricity flickered out. Transport ceased. Communication failed. The Underground Reich, conceived as a sanctuary from air power, had never been designed to withstand territorial conquest. The turning point was not a single battle. It was the convergence of forces: air superiority, ground encirclement, fuel depletion, logistical fracture. When these elements aligned, underground relocation could no longer compensate. By spring 1945, the Underground Reich was not defeated by direct penetration of tunnels. It was defeated by isolation. Factories remained physically intact in some cases, but disconnected from fuel, transport, and command, they were inert. The mountains stood. The system inside them did not. Could underground expansion have succeeded if begun earlier? Possibly it might have delayed industrial losses, but long-term victory required more than protection. It required sustainable resources and strategic flexibility. By 1944, Germany lacked both. The Underground Reich was a rational adaptation to bombing. It was not a solution to total war imbalance. As April 1945 approached, Allied soldiers entered regions once sealed in secrecy. They discovered rocket components, unfinished aircraft parts, and vast tunnel networks. But they also discovered evidence of forced labor and mass suffering. The story of the Underground Reich shifted. It was no longer primarily about engineering. It was about cost. The landing in Normandy had opened the Western Gate. The Soviet offensive had shattered the East. Between them, the Underground Reich was compressed. Its strategic value diminishing, its moral burden expanding. Inside the tunnels of Mittelwerk, there was no sunrise, there was no sunset. There was only artificial light, weak bulbs strung along damp ceilings, and the endless echo of machinery against stone. The underground program depended on a system already in place: forced labor administered by the SS. Mittelbau-Dora functioned initially as a sub-camp of Buchenwald. Prisoners arrived from across occupied Europe. Political prisoners, resistance members, Soviet POWs, Jews, and others classified by the regime as expendable. They were divided into work details, or commandos. Some drilled into rock, some transported rails and equipment, some assembled rocket sections, some installed wiring and fuel lines. Guards enforced discipline with violence. A perceived act of sabotage could result in public hanging. A slowed pace could mean beating. Illness often meant removal and disappearance. The logic was brutal and mechanical. Production above all. Replacement over recovery. If one worker collapsed, another would be assigned. The system treated human beings as components. Defects were inevitable. Supervisors demanded higher output. Engineers revised specifications repeatedly. Parts were modified even as assembly continued. In such conditions, error multiplied. Early production batches saw high failure rates. Some rockets exploded shortly after launch. Others veered off course. The paradox deepened. The regime demanded technological perfection. It imposed conditions designed to guarantee imperfection. Elsewhere, underground facilities were prepared for chemical production. Germany had developed nerve agents, including sarin, before the war. Plans for mass production existed. Though large-scale deployment never occurred, The infrastructure indicated intent. The same logic applied. If exposed facilities could be bombed, they must be buried. Yet even here, strategic hesitation prevailed. Fear of Allied retaliation, logistical complications, and the deteriorating military situation limited use. The possibility lingered in tunnels not fully realized. Inside Dora and other camps, discipline extended beyond work shifts. Roll calls lasted hours in cold weather. Punishments were staged publicly. Hierarchy among prisoners was manipulated to maintain control. Kapos, prisoners appointed as overseers, sometimes enforced orders with severity equal to guards, seeking to protect their own positions. The atmosphere bred mistrust. Solidarity existed, but survival often required silence. The Underground Reich demanded secrecy from the outside world. Inside, secrecy meant survival strategies. Many engineers involved in rocket development later claimed limited knowledge of camp conditions. Some admitted awareness of forced labor. Few acknowledged direct responsibility. The ethical question lingered. Can scientific advancement be isolated from the means by which it is achieved? The V2 would influence post-war missile and space programs. The knowledge extracted from underground factories would shape Cold War arsenals. Yet its origin lay in tunnels filled with suffering. History rarely presents pure achievements. It presents entangled ones. Long after machinery stopped, the tunnels held silence. But survivors carried memory. The Underground Reich demonstrated the extreme intersection of industrial ambition and state violence. Advanced combustion physics, jet propulsion, submarine hydrodynamics, all achieved while human beings were reduced to expendable labor. The hell within was not metaphor. It was literal. Darkness, dust, hunger, fear, and the relentless demand for output. From a purely military perspective, the underground system failed to alter the war's outcome. From a moral perspective, it magnified the regime's crimes. The tunnels were intended to preserve strength. They exposed weakness. They were meant to shield industry. They revealed the cost of total war pursued without restraint. The Underground Reich was not defeated solely by Allied armies. It was undone by the system that sustained it. By April 1945, the geography of the war had closed in. From the east, Soviet artillery shook the outskirts of Berlin. From the west, American and British forces crossed the Rhine and surged toward central Germany. In the Harz Mountains, the tunnels of Mittelwerk still stood intact. Machinery remained bolted to stone floors. Assembly frames lined the galleries. But production had slowed to a shadow of its former tempo. Electricity was intermittent. Transport was unreliable. Command structure fractured. The Underground Reich had been designed to survive bombing. It had not been designed to survive encirclement. As Allied armored columns advanced, SS units received orders to evacuate prisoners and destroy sensitive documents. Some equipment was sabotaged. Much was simply abandoned. The mountains did not collapse under explosive force. They fell into silence. From a military perspective, the Underground Reich represented a logical adaptation to overwhelming air attack. Relocation reduced vulnerability. Dispersal complicated targeting. Yet relocation alone could not overcome strategic imbalance. Germany faced material shortages, manpower depletion, and encirclement. Industrial protection did not generate fuel. Secrecy did not restore air superiority. Engineering did not compensate for shrinking territory. The Underground Reich bought time. It did not buy victory. The legacy of the Underground Reich moves in two directions: forward into modern rocketry, aerospace engineering, and the militarization of space; backward into memory, testimony, and the ethical lessons of industrialized coercion. Both are inseparable. To examine only the technological triumph is incomplete. To examine only the suffering ignores how deeply intertwined innovation and power can become. The story demands complexity. What was built in darkness eventually emerged into light. The Underground Reich stands as both innovation and warning. Innovation can survive defeat. Warning must survive memory, because the question it poses is timeless. How far should a society go in pursuit of survival? And at what cost?